recording.
Okay. Right. Now, as Dr. Buddhita explained about the workshop, so this is about natural language processing. When it comes to languages, there are two types. One is a natural language processing and natural language generation. Right. I think you all know about the language generation, which these days, which is a very I can't say trending because it has taken over, I would say. Now, if you look at those natural language generation or generative AI, we all know what scale that we can go into. You may have heard about BERT models and everything. But today what I'm going to do is we go back to the basics. First, I introduce some of the applications. Then I can showcase you what you can do with this, even with the basic techniques using some tools. Right. So if you have any questions, please do not hesitate. Stop me at any time. Right. Stop me at any time. Sorry. And raise your questions. We can take this as a discussion. I don't take this as a standard lecture student mindset. You can simply stop me and ask questions. Or if you wish to clarify something, if you want to comment on something, please go ahead. Now, I'm pretty much sure many of you have learned V's in big data. Right? So we have learned about volume, velocity, variety, veracity. This is not a new thing for us. I mean, when we were learning, it was 3 V's, but now 5 V's, and then we have many V's. Right? You can see here itself we have 10 V's. Now, when we are looking at data, we don't get all V's at once. Now, that's a sort of the pattern. If you look at the standard, what do you call supermarket data, you have the high volume data, no question. Velocity also very high, right? You will see large number of customers coming into the shop, so velocity is also very high. But variety is not a factor. Probably your data will be in a standard Oracle or SQL Server or MySQL database. It's a structured data. So variety might not be there. Veracity again might not be there. Veracity means the accuracy of data. So it might not be there also. Data is accurate in most of the cases. When you buy something, right, those numbers will be validated by the cashier, so you are entering it. So veracity factor, there may be veracity factor with respect to the customer information, but not in large scale. So if you look at all these aspects, you can see, even though we discuss about all these V's will not be available in one place. But if you look at text data, just look at the reviews of customers for a website. Of course, the volume is very high. Right? There will be large volume of data, right, that is coming into the database, into the websites. Velocity, right, very high. These are public data, so people are entering data from different places, different countries. So therefore, you will have the large number of, higher velocity. Variety. Now, these are free text entries, right? People can type in different languages. People can type in different the context. There can be grammatical mistakes, right? Everything can happen, right? Everything can happen. So therefore, variety is also a factor there. Now, veracity again very high because these are the data entered by people. So how do we know the accuracy of this data? Now, I can enter anything, right? there are fake profiles nowadays. So when you look at text data, you will see all these at once, right? You will see all these at once. So that is the challenge that you will have with text data. Now, this is not sure that you can see this. So there is a classification done by uh, a book called Data Mining. So they have identified complex data sets, right? So they have identified complex data set. One of those data is, I'm not going to explain all the things here. One of these complex data is web and text data, among others. Right? For example, time series data is complex, and social network data is complex. Biological sequences are complex, and on top of that, web and text data is also complex. Why it is complex? Because we have many. All these are there in the text data. So before we move into NLP and its applications, we need to understand. We are moving into we are starting to analyze data which is complex. So therefore, when you're analyzing complex data, it is little difficult to come up with higher accuracies, right? Higher accuracy. So therefore, we don't expect very high accuracies with respect to natural language data. Number one. Number two, uh, when it comes to text data, for you to make good to come up with a good result, you need to have substantial volume of data. Why? There can be a lot of differences. So therefore, you need to have somewhat large volume of data. So if you are starting to do any application development for NLP with 1,000 data, it might not work. 1,000 documents, it might not work. Right? So you need to have substantial amount of data. What is substantial is depends on your case. Right. So let's look at a few case studies before moving into some applications. So this is sentiment analysis. Very common, I would say, very standard thing that we can do. We will do this. I'll be running through some of the examples during the uh, later part of this lecture as well, right? That is sentiment analysis. By looking at data, can we say whether this is a good sentiment or a bad sentiment? Forget about the machine stuff, machine learning stuff. As a human, can we do that? If I ask you, as a human, as a human, by looking at a data set, by looking at a text data, can we say whether this is a positive sentiment or a negative sentiment? We can do that. We do these things, right? By looking at an article, by reading an article, we will say, okay, this is good sentiment, positive sentiment, right? These are, again, now these days I'm involving with a research with a with the students in UK, Sri Lankan. Now I don't know whether you know the context. Very recently, UK election was concluded. Not very recently, around 3 to 4 months back. Now we are looking at, by looking at the news articles, can we predict outcome of the election? Can we predict the sentiment of people? As you know, in UK there are two main parties, uh, Labour and the other party, uh, Conservative. So we are looking at the articles, news articles, and see whether there are positive. No, there can be two things. There can be positive towards Labour Party, negative towards Labour Party, right? On the other hand, it can be positive towards the other party, negative towards other party. So we are looking at all those four elements, right? By as a human, we can do that. As a human, we can do that. But if you look at, I mean, how many articles we can do this, right? But we can make mistakes, right? So and also we need to understand when we are making such a prediction, we have a background also, right? We have a context into this, right? I'm favor of let's say conservative party. So if I'm favor of conservative party, I will look at that article on that perspective. So human can do this, but there are a lot of other barriers. Here the sentiment analysis, what we are going to do is by looking at a text, we are predicting whether this is a good sentiment or a bad sentiment. So we will be doing this example little later for the movie reviews. By looking at movies, how are we going to predict whether they are negative movies or negative sentiments or a positive sentiment, right? Right. So then, what is the help of? If you look at the movie example, so I have in that particular example, I have 2000 reviews, which is a very common IMDb database I have used. In that particular example, there are 1000 negative movies and 1000 positive movies. Now, if you have identified the sentiment of if you can identify the sentiments by positive sentiments, they can they can do the advertisements using the negative positive sentiments. By using the negative sentiments for a future movie, they can use it. So that is how you can use this positive or negative sentiments, right? I will discuss how we have used it for some other organization as well, right? So uh, information extraction and sentiment analysis, where now if you want to analyze product, right? Let's say you want to analyze a product on their features by looking at the customer reviews. If you go to Amazon, right, there are products. Now, when you buy a product, so there is a review, you might have seen the stars, right? So 4 stars, 5 stars, 3.5. Likewise, you see the average stars. But when you see that, that doesn't give you the entire picture, right? That doesn't give you the entire picture. Why? I might have rated because of the price. You might have rated because of the features. Someone else might have rated it for the services. So you will see, we want to see the sentiments on the different aspects of their comments. This is again the research done by students. I think the research paper is available in IEEE, where by looking at the add-in is also available. You can add this into your web browser and then you can use it, right? You can use it, right? So likewise, you can go into the details of product. So that now, for example, this one, if I look at this one, I will see okay the camera ease of use is people are not very happy with the ease of use. So if I'm a very novice for the camera or the photography industry, I would might not buy this, right? But again, you can see the other features, flash, zoom is okay, right? So that's how we buy a product, right? You don't simply buy a product because of one feature. We want to look at different aspects of these features. Then document retrieval. Now we have large documents. We have high volume of documents, right? If you look at a news archive, if I want to access news, I would want to have a clustering data, clustered data, grouping. If I want to see the what do you call? If I want to see the uh, what do you call news on sports, right? I would want to see the sports. Or if I want to see the news on what do you call what politics, right? So that cluster should be there so that I can easily access the articles. So one article can be into multiple domains. For example, when you look at an article, it can be classified, grouped depending on the location or the geography. Another news article can be grouped depending on the type, sports, political, science and technology, like or the language likewise. So there can be many classification, many grouping, right? So by looking at all these aspects, if you can have a natural grouping, it might be easy for us to access this data. I think this is something we all deals with. I just imagine if we don't have a spam detector, that if we don't have a spam detector in our mail, what will happen, right? So you all know, right? What it does is by looking at some properties, right? Not only the content, by looking at some other parameters, it will detect whether your mail is a spam mail or a normal mail, right? Uh, Now we did another research into this. We extended this research. Now, if you look at your emails, sometimes you receive emails to your inbox which are not spam but not important. Right now, for some example, when you are working for an organization, you tend to get emails from the organization, right? For a general email, which is not much interest on you. Sometimes your inbox has how much? I don't know what my number is. You will have an inbox of more than 10,000 unread emails, right? Sometimes in this unread within this unread emails, you might have mails which are very important, but for some reason, right, it has hidden through the other unnecessary emails. So we did a research to by looking at the email content and other parameters in your inbox. What are your important emails? Right, all these papers are available. All these papers are available. Uh, if possible, I will include them. I have not included them as a separate slide. Uh, what I will do is I will this slide set. I'll post it to somewhere. With that, I will include those research article papers as well. Right. So this was the real story. I'm real. I'm why I'm saying real is all the others are also real. This is a really I mean, how can I say? The story that has happened in not just a research. Okay, let me put it that way. Not just a research. These are actual work that was implemented. So two books. Now, if you look at these two books, Into Thin Air and the Touching the Void, even though I have, when you are reading a slide, you read from left to right, right? So naturally, the first thing should be Into Thin Air. However, the Touching the Void is the book which was first published. Now, story goes like this. This is by a mountain climbers who set of people who climb the mountain Andes uh, in from Peru, if I recall correctly, and they went into Andes, and then they had many issues. You know, this sometime when you are climbing this high mountains, right? They lost their way, and then somehow with a lot of difficulties, they have come back, right? So after coming back to Peru, they have written a book. The one person, Joe Simpson, was a crew member, and he wrote a book on touching the void. Not a major incident, right? No one knows. I think if I recall correctly, this happened in the 80s, early 80s. So not a big deal. Not a big deal. So okay, right? So it was a standard selling book. After 10 years' time, another two teams actually climbed the mountain Everest. Where in this what do you call documentary is available. You can watch that documentary. There's a film documentary, all names after Into Thin Air. So these two groups, due to many other issues, due to many issues, many other management issues, some technical issues, environmental issues, 13 people died. To date, that is the worst accident that had happened on the Everest mountain. I still remember, I think this happened in 95 or 96. This was telecasted in Sri Lankan TV channels as well, news channels as well. I mean, as for news as well. Little, I mean, incident, right? I mean, it was a focus incident. So then, after uh, this book, after the incident, the person called John Krakauer wrote a book on Into Thin Air. Now, this book was was selling well. Of course, right? You have these news items behind you, so people wanted to know what was gone wrong. So the people are buying this book. Suddenly, Amazon realized from their the techniques, they realized there is a similar book called Touching the Void, which was published a decade ago. So what they did was they started to market this book Touching the Void as well. Similar book to Into Thin Air. Then what happened? Suddenly, Touching the Void, people start to buy the starting Touching the Void book. Why? Now they have never heard about this story. They have, because it was not very popular. So they started to when they started to realize that there was a similar incident to uh, what do you call Into Thin Air, people started to buy the Touching the Void. Suddenly, touching the void sales went beyond the Into Thin Air book sales. So using NLP techniques, they have identified these are similar books. These are similar books, right? So that is how you look at this, the application side of NLP. Right. So what can we do? What can we do with this uh, language technology? Of course, spam detection. Just imagine life without a spam detection, right? Just once in a while, go to spam and see what are the data that you have, right? Then part of speech tagging. Now we call it post tagging. By looking at a data, by looking at text, there are language rules, right? There are language rules. We have to identify whether the adjective uh, or a noun, verb, right? For example, chairperson sit on the chair. Chairperson was sitting on the chair. right? Chairperson, someone is chairing the session. So you will see the same chair word is used, but one as a noun, one as a verb, right? And chairperson, you can call it a adjective. So same chair is being used at different places for different reasons. Now, in English, right, it says English is a verb-based language, right? So therefore, they will derive. Now, for example, they can say, "I telephoned." Telephone is a verb there. I telephoned is a verb there. I tell you. So, and when they say my telephone is broken, that is a noun. So for you to understand the context, you need to understand whether this is a noun or a verb. So that is called post tagging. Name entity recognition. Now, when you look at a language, right? Language, there are many entities, right? There are many entities. One is person can be there, organization can be there, location can be there, right? So depending on these properties, right? Whether it's a person, organization, these are the three common things that we look at from the NER. But there can be extensions to date, events, right? Likewise. Then, of course, sentiment analysis. Sentiment analysis, right? Uh, Whether it's a good sentiment or a bad sentiment. Then, co-reference. Now, Carter told Mubarak he shouldn't run again. Now, who is he? Carter told Mubarak he shouldn't run again. If you go by English, you might think he is Mubarak without looking at any political context into this. But if you look at the political context, this he may not be Mubarak, but it might be Carter. So this Carter is Jim Carter. Mubarak is Hosni Mubarak. Jim Carter was the president of US from until up to 79, from 74 to 75 to 79. Why I think it's not Mubarak but Carter? Because Carter, when you say run here, run means what? These both are not athletics, right? They are not athletes. So therefore they are not. This run not is reference to nothing to do with athletics, right? So this run means politics. In election, politics means campaigning or so when you are contesting for the election. Now, Mubarak being the president of Egypt, they don't have election. But in US you have election. So in that context, so this he is Carter, not Mubarak. Now you see, right? Now that is where the natural language processing might fail if you don't go by the context. If you simply analyze the English meaning, here he would be Mubarak, right? But if you look at actually Carter lost his second time, right? When he contested in 1979 against Ronald Reagan, he lost the election, right? So probably that might be the reason he is saying he shouldn't have run. So see, right? So here it's not only about this simple sentence. It's about all the context around this the text. Mouse, you all know what you can, right? I need new batteries for mouse means not the mouse who runs on top of your roof, right? Right. So machine translation is very common thing that we use nowadays, right? Translation, which is very common application or other, yeah, right, that we use, right? Uh, Now there are a lot of tools as well. I was couple of months back. I was at Polonnaruwa. I saw a tourist guy was talking to some European tourist. So what he is doing is he had an app on his phone. That person is asking questions, and that is translated to from the app. It is translated to not sure the Sinhala or some other language. And this guy, the the guide, is talking again to the phone, and that is translated back to the that particular person. So machine translation. So now you can think that you don't need that level of knowledge when it comes to this when you want to, if you want to improve the tourism. Information extraction somewhat relevant to the NER. Now if you received a mail, you are invited for our dinner at uh, at uh, can you give me a 1 minute? Right. So if you received a mail call mail like this, most likely you will neglect it. But what if by reading the mail body, by reading the mail body, uh, it can, if it can generate a calendar invitation for you. Google does this. Google does this. Sometimes if if you received a mail saying that I'll be arriving at the airport on this time, date and this time, you it might create an event for you, right? But now you know, right? So those are the possible applications. But with the extensions of generative AI, now the question answering is not very hard, right? And then summarization, right? Summarization. Now it has gone into the extent of video summarization as well. Then the chatbot, which is very common, right? Very common now. Not very recently, around 10 years back, I have seen chatbot in most of the countries. In Sri Lanka also, you have chatbot now, right? Rather than directly calling a person, a physical person in person, you call uh, you uh, talk to a chatbot in order to resolve your issues. So these are the variety of application that you can think of. Right. Okay. Right. Now, if you remember on the very first slide that we were talking about the V's, we were talking about variety. Variety means variety can comes in different ways, right? One is language detection. Now, when it comes to users text, right? When it comes to users data, you will see people will enter data in different languages. Different language. Now, when it comes to natural language processing, it is depend on the language. For example, NER, post tagging, part of speech tagging, they are dependent on the language. Right? Every language has its own properties. And for example, as I said before, English is a verb based, Sinhala is noun based. Very simple terms. Huh? There are many differences. Now, in Chinese, there are Chinese and Japanese. Now, if you look at Chinese alphabet, you have in Sinhala, in English alphabet, 26 letters, Sinhala 32, in 32 and 52, there are two different alphabet for us, right? Mixed and unmixed, 32 and 52. And then Chinese, they have more than 1,000 or something, 60,000 something language, the letters, because they have graphical letters. Now, if you look at Arabic, you read it from right to left. Likewise, there are different properties of each language. So therefore, before applying your task applications, first thing you should do is detect the language. Detect the language. Now I'll tell you application side of this. Two applications. We were doing a research for EWOM. EWOM stand for word of mouth. Word of mouth means Facebook mainly, right? Gossips, right? Nice term is word of mouth, right? Now, we want to analyze product quality, product healthiness, and their prices using word of mouth. So we were looking at some data. We were scraping website. This happened around 4 years ago. I think you remember. Probably you might remember. There was a incident where one government official said it is okay to have little of arsenic. Like those days, we were doing this research. So by looking at people's sentiment, we want to see the prices, whether the prices are high or low, and the what do you call, the healthiness of these products. So we were scraping the data. I can't exactly remember the numbers, but when we were looking at the data, I'll just give you rough numbers, but the same sort of a same in line, right? Now, English text, English comments. There were English comments around, let's say 60% of English comments were there. Right. Then we were specifically looking at some products. If I recall correctly, the paper is available, but it's so we were looking at some fast food items, and 70% of data is in English, so we have no issue. Some 15% in Sinhala, another 15 or no 20% in Sinhala, another 15% in Tamil, another 5% in Singlish. Singlish, right? Romanized English, that's how you call it. So now we had two options. One thing is we can ignore those non-English terms, non-English text. But if we read, what will happen? If you look at this particular research is looking at the research is to focus on the or getting the what do you call the products, price and healthiness. Now for that particular research, Sinhala and Tamil text are very important. So therefore, we can't simply ignore these two sets of data. So then we decided to, okay, we did the language detection. There are libraries, I will show it to you a little later. And then after detecting the language, English and Tamil texts were translated into English. Fine. Right? No issues. We had the Sinhala, the text that was translated, Tamil that was translated. So then into English, from that onwards, we can work on that particular data. Singlish 5%, we decided to ignore that. There were a couple of research done at University of Morato regarding the Romanized Sinhala and Romanized Tamil. But because of the number is very small, 5%, we were able to ignore this. In the previous two languages, if you look at the Tamil and Sinhala, that amounted for 35%, which is something you can't simply ignore. And so therefore, we decided to translate those two. Right? So that was the use of language detection. Another example on language detection, we were doing this is not a research, this was just a project for a organization where they have this what you call tool where employees can post their comments. Employees are right, so not matching the right, so they have platform where people can enter comments. It can be natural comments, or it can be sometimes it can be what do you call it can be on salary issues, right, on some technical issues, in say some technical discussions about tools and some processes, right, or it can be about some facilities, right. So they want to do a sentiment analysis on these data, right. So we did this test. Initially, we found that, so okay, this particular organization they had branches, the branches around the world. One in Sri Lanka, two in India, one in US, another couple in Europe likewise. So when we analyze that data, we realize something around 3%, 3 to 5, less than 5%, that I can remember, is on non-English data. So if you look at this context, organization, IT organization, then we can simply ignore those 3%, right? So there we ignore this 3% of data, right? Let me conclude that research as well, right? So that will be a good example. So then we did by excluding this 3% of data, we did a sentiment analysis. Now in this sentiment analysis, right? So we give a sentiment score. So then the HR can analyze what is the location-wise sentiment score. Sri Lanka sentiment score is this. India sentiment score is this. India, this location sentiment score is this, right? So likewise, they analyze the sentiment score. Then they can further analyze the sentiment score depending on the gender, right? Females are happy or what? I don't know, right? Some sentiments like this. Now, also designation-wise sentiments. Then project-wise sentiments. So HR can do HR did a lot of analysis with these sentiments, right? So that's the sentiment analysis, how it was done using the data entered by the employees. Now I will show you how this right, how this can be done. There are libraries are available. I'm not going to run this library. Now these are some data. You can see some data. Even the Sinhala is also there, right? Sinhala, Tamil, right? So then, by running these libraries, I'm not rerunning this, right? It was disconnected, right? You can identify what language is this, right? So English is this much. Hungarian, Russian, Italian, Japanese, Tamil, French, I don't know what DA stand for, Norwegian, Estonia or Lithuania, I can't remember, German, UK, Ukraine, likewise, so you can identify the language, right? And then actually I extended this by writing this simple Python script where if I want only one language, I can simply, if I want only Tamil, I can get only the language in Tamil. So likewise, I can separate out the language, then I can using the Google API or whatever, I can translate. Now remember, whenever you do something with NLP, first thing you should do is language detection. Why? Depending on the language, your applications, your decisions can be changed, right? The classical example is this. If you are ignoring it or you are translating it, it's your choice. but that has to be scientific. That has to be scientific, right? You can't simply ignore it if it is very large amount of data, right? So look at those two contexts. E1, we had to take the English the data. Sorry, we had to take the single data by converting and translating, and on the other hand, we had to take the other. We had to ignore the non-English data because they are small in numbers. And also the context wise, it doesn't make any sense to translate them as well, right? So then someone can argue, okay, if you are missing 3% of data, will that has an impact on the accuracy? Technically, yes, but thing is, anyway, with the accuracies that you can gain is not very much compared to having those 3% of data, right? So you are okay to ignore those data, right? Rather than try to translate. In that particular example, we were looking at multiple languages, right? I exactly can't remember the number of languages, but then uh, rather than try to translate each and every language, it is much easier to ignore. So this is for practical reason. Right. So let's move. I have given some resources which you can read next. Right. Now I will do some demonstration using a tool called Veka. Right. Right. So I'm using a tool called Veka. Again, good tool for academic purposes, right? So that I can showcase some of the theories with respect to this NLP, right? So this tool is developed by a university in New Zealand, University of Waikato. Right. Before I run into any natural language things, let me run a simple prediction model or a classification model for a structured data, not for a language data. Right. I will open a file. Hope you can see the screen. If not, let me know. I'm opening the. Right. So let me open this data set. So here you will see I have how many data. This is a diabetic data set. So I can get the numbers from here. Right. So I have 768 data. Right. So if you look at this data, this is the whether you are a diabetic patient or not, right? Positive and negative, tested positive and negative, and what are the other independent variables? Sorry, what are the other independent variables, right? So I'm not sure about these parameters. Only thing I know is the mass, the weight, right? And the age, of course, right? So there are 8 parameters, right? That you from that parameters you can say whether this guy is a what do you call uh, whether this guy is a diabetic patient or not, right? So you can see the uh, 8 parameters, right? I don't know what these are medical parameters. They have collected those parameters, right? So now if you build a machine learning model, right, I can simply choose a decision tree model, right? Now what I am doing here is, right, I think you may have learned machine learning in some of your lecture, but in case you have not, we build a model. This is a prediction model, right? We build the prediction model. But after building the model, how do you verify this model? Now, why? Okay, you have built the prediction model, right? So there are many techniques to build the classification prediction model. I'll give you a few examples. One is SVM time, rather SVM decision trees, random forest, naive Bayes, and artificial neural network, multiple. Likewise, there are many techniques. This tool itself has, right? You can see the techniques here, 6 here, right? Something here. Likewise, there are many techniques, right? You can see those techniques. Now, if I ask you why you choose that the decision tree, why not others? How do you say your model is best with the decision trees? Now, once you build the model, you have to verify your model, right? Which is very important, right? You can't build a model and say, here, I have built the model, come and use it. People will ask, okay, fine, we will use your model, but why? But why we should use your model, right? So that is where this evaluation criteria comes in. Typically, what we do, there are many other techniques, but the most common technique is the split rule. We split our data set into two, training and testing. We will use the 80% of data, in this case 80%, which you can configure, 80% of data to build the model. Then rest 20% will be used to test the model. Now, let's say by using this 80%, you have your model is built. Your model is built. Then once the model is built, rest 20 data points, right? You know for these data points, okay, age is this, mass is this, other parameters are this. Then from the model, you will be asking, right, for these parameters, what do you think? Whether this guy is the diabetic patient or not, or non-diabetic patient. Model will say something. Then what do? You evaluate with your actual data, right? So then from that, let's say out of this 20%, but let's say out of the 100 records, 75% is correct. Fine. So your accuracy is 75%, right? So that is how you verify, test your model. Now let's do this for this diabetic data set. Now you can see as soon as I click this, you got this data. Time taken was 0.06, less than, right, less than 0.1 seconds. right? Less than 0.1 second, right? How quickly it was able to develop. Now you can see, let us go by some values here, right? Now, so let's do few mathematics here. So if I go by the number 768, so 768 into 20% means 154. If you add these two, you will get 154. So basically, out of that 768 data points, right? It has used 154 data points to validate my model. Now, out of those 154, 117 data points were correct. 117 data points were correct. 37, there is an issue or invalid, which means accuracy is 75%, right? And also it gives you a confusion matrix. Right? So let me explain this. Again, this is nothing to do with text data. Right? This is nothing to do with text data, right? Let's see how we can do the same thing for the text data as well. That's what our target would be. Right? Now, if you look at how do you read this 86 means they were, this side is actual, this side is predicted or the classified. They are actually A and predicted as A. Tested negative, classified as A. A is tested negative. So 86 is they are actually A and predicted as A. This 31, they are actually B, predicted as B. If you add this 86 and 31, you will end up with 170. You will end up with 170. Right? And these two are the error records. This B means these are actually A but predicted as B. This 18 is they are actually B but predicted as A. If you add these two, that will become 37, which is what you see here. So basically, this 37 means there are two types of errors. One is they are actually negative but predicted as B. And this positive, this 18 means they are actually positive but predicted as B. Both are errors, no doubt, no questions. But out of these two errors, what is most significant? Telling a person you have diabetic for a person who don't have diabetic, or telling a person who you have no diabetics but he has diabetes. What is most significant? That's context. It's contextual, right? You can't simply go by mathematics there. Okay, go back to our corona days. Right? Corona days. What is most significant? Telling a actual corona patient that you are not infected with corona, or telling the non-corona patient that you have corona? What is most significant? See an answer here. It says false negative. If you can explain the context, let's forget about this. Forget about this technical jargon. Let's look at this contextually. Let's look at this practically. What is most significant? Telling a patient that you don't have any illness, or telling a non-patient that you have this illness? Yeah. So I have answer from yeah. Someone is saying two. I can't remember what the two is. Right. Okay. Not identified. There's another answer from Dinusha Idrivira saying that not identified signals. Yes. Most important thing when it comes in lot of medical examples. In lot of medical examples, when we are looking at machine learning applications, we are more concerned about the identifying people with the illness. So here this 18 would be more significant, right? This 18 would be more significant, right? Because they actually they tested positive, but we have not identified. This 19, yes, I'm not saying that 19 is good. If you have too many numbers for 19, that is also a problem, right? You do unnecessary test and you take the rest and everything, right? So, right? So that will run into a different issue. But I'm not saying out of these two errors, I'm saying out of these two errors, this one is more significant. That is what I'm saying. I'm not saying you can ignore 19. No, right? The out of these two errors, 18 is the most significant error. That is what you call recall, right? So out of the, if you look at here, now our model is what? Identify the positive. There is a question. If you don't have a disease, you don't test for it. Okay. If you don't, I didn't get that. If you don't have a disease, you did not test for it. No, but if you remember, uh, not really, right? In medical test, you don't do that, right? Medical test, you do checkups. Corona days, right? We used to do the test, right? When someone coming from outside, we tested them, right? Whether you like it or not. We do the diabetic testing, right? So it doesn't. It's not always that when we have a disease only we go for the test, right? We do checkups, right? So checkups means, now for example, right? I have another data set. I can open it little later. The cancer test, what do you call breast cancer data set. So sometimes you go for test even though you have a disease, right? So it's not necessarily that you go for a test whenever you have a disease, right? Now, if you have a fever, you go for test. You test for, okay. Let's take that example. You have a fever. You go for a dengue test. Okay, you accepted that, but let me explain this. Right? You go for a dengue test. But then it might say you have dengue, or it might say you have not infected with dengue. Or that again can be wrong, can be right as well, right? Right. So it's not necessarily uh, that is can be ignored. Okay, you accept. Right. So I was at now our model is what our so always look at the context. That's what my golden rule. Don't go by this technical jargon. Right. Why we have built this model? We have built this model, this particular model to identify diabetic patients. So our focus is identifying diabetic patients. So in our sample, we have 49 diabetic patients. Can you see that? Right? This is actual. This side is actual. This side is predicted, right? In our sample, we have 49 diabetic patients, right? 49 diabetic patients. Our model has, out of that 49, our model has identified 31 patients. So what is the number, right? Out of 49, we have identified 31 patients. So we have a percentage called 63.26, which is rounded up. That is what you mean by recall, right? So here, even though my accuracy is 75%, my recall is not very good. My recall is not very good, right? With respect to the positive patients. Now, remember, this is the tool, right? Tool does not know whether you are looking at negative or a positive. So tool gives you both values. The recall for negative, recall for positive. But our focus is what? We are building a model to identify the diabetic positive patients. So we should focus on this, not the negative side. So you would see here, even though the accuracy is 75%, my recall values are not very good, right? So that is how you select a model, right? Now let me do this for a, let me run this for another, let me do this for a random for us, another classification technique, right? You can see, okay, now see, it has increased the accuracy, but look at the recall, worse than before, right? Even though my accuracy is very close to 80%, my recall is not very good. Out of 49, it has identified only 29, 20, right? 20 patients are not identified. So I'm not happy with this model. We choose few models. But, okay. Okay. Still almost same, right? So the 60 something was the, let me do, I don't think logistic might, I think this one. So look at this. Accuracy is 70%, by my recall is 10%. So don't just go by the accuracy. Accuracy is not the correct measurement when it comes to classification. I'm setting up the ground. We have not done anything on the text analytics, right? Just to do cover this, let me do another test on another data set. So this is a iris data set, right? So they have 150 records for 3 classes, right? So depending on the sepal length, sepal width, petal length, petal width, you are classifying a flower. You are classifying a flower, right? So they are, let me run. So now if you look at this model is 100% accurate. Look at this. Look at this confusion matrix, right? We have 30 records right? All 30 records are predicted correctly, right? So no issues at all, right? Now, if I go back to the slides, I'll come back to these slides a little later. I'll be discussing all this, but just want to give you what are we planning to do. This is what our plan is. Now, if you look at previous examples, two examples we did on one on text, rather the diabetic patients, and the other one is on the petal length and petal, rather the verse, what we call that, flower data. Now there we had nicely structured independent variables. But now in text, what are we going to do? We are going to do, by looking at this text, we are going to say whether these are positive or negative. Right? We are going to say these are positive or negative sentiment. Now to do this, I will open a text data set. So before that, I will show you the data set. I will right. So these are movie reviews, 1,000 negative reviews and 1,000 positive reviews, right? So these are those reviews, right? So these are reviews, and they have targeted it to say these are negative, right? So this they are negative comments. So now, right, just analog this to the previous example, diabetic example. In diabetic example, we had age, we had weight, and 6 other parameters, and then we have the class variable, which is negative and positive, negative diabetic and the positive diabetic, right? In the text data, we have a text, bunch of words, and then we have a label called negative and positive. Right? I missed something. I quickly come back to that. If you look at here, I can view the tree as well. Again, this tool is not very, sophisticated tool, mainly an academic tool, right? So here, this is what this decision tree is, right? You can build a decision tree here. I'm showcasing you this. Let's compare this once you do this for the text data. Right. Now again, so if you go back to our discussion, we had diabetic data with 8 parameters, age, weight, and some other medical parameters, and it says whether you are a negative or a positive diabetic patient. If you look at the iris data set, you have 4 parameters. You have 4 parameters: petal length, petal width, sepal length, sepal width, and then the flower. Now here, you have a text and the negative and the positive. So if you look at the negative and the positive wise, it's similar to the diabetic data. However, we have a much bigger challenge than that. Why? In the diabetic data set, we have very structured data, but here we have very much unstructured data, right? So let me open this data set in Veka. So if I open this data set, right, this is my text and this is negative. This is my comment. This is positive. This is my comment. This is negative. So if you look at this parameter, class variable, that is available in both cases. In both cases. So anyway, for you to do any classification related activities, you need to have a such classification variable. That's why we call them as supervised learning, right? You need to have a defined class variable, right? So we have that now. But now the task is, how do we use this particular text to analyze this? Now, if I ask you, right, and I'm pretty much sure you don't answer you won't speak here, but how do you identify this text is positive sentiment or a negative sentiment? Okay, let's drill it down. For you to understand this data, this text is positive sentiment, what are the possible words that you will have in the text? Can you, if you can speak, I'll be much happier, but if you can't speak, you can type in the chat as well. Yes. What type of words you will see for a positive sentiments? Good. Okay, there are coming in good, satisfied. What else? Good, satisfied. What else? What are other words? Now, isn't that what we do in our day-to-day life as well? Right? If I go back, right now, when we are reading some novel, how do we identify, okay, this novel is related to this? Okay, I'll tell you another example. Now, how do you identify? You're probably you are listening to music, songs. Awesome. Okay, other texts are coming in. By looking at by listening to a song, how do you say this song is written on university, about a university? By listening to a song, how can we say this song is written about a university? There are some keywords, right? There are some keywords. Sarasavi, Bhantana, Mahavali, Roborosia, whatever, right? There are a lot of things. So there are keywords. So we use those keywords to identify the context, right? Now, Nirmal, right? He has written three keywords which are used to identify the positive sentiment. What are the keywords that can be used? Okay, there are many things, right? Awesome, fabulous, great, nice, right? It can go into different, many other vocabulary. Right? What are the negative? For the negative sentiments, what could be the keywords that you will see? Yes. Yes, what are the keywords? Disappointed, yes, good. Disappointed. What else? Sad, unhappy, right? So you identify the context, right? Right. So that's how you look at the context. So when it comes to language, right, it's very important to identify the context. Or it can be so now these are context. Right? It can be now similar terms, right? For example, to identify uh, the university song, similar terms. Another one is objects that you see. What do you call Mahavali, Hamtana, right? Sometimes activities, right? So all can be related to identify a context, right? But sometimes it can go horribly wrong. Sometimes some keywords may be used may be used to identify different contexts. Again, if I go by the song example, right? If you look at mother, right, you might think, okay, Amma would be the keyword, but you might see that keyword will be used to explain many other things, like for example country, school, sister, father, right? So so right so so you see the challenge here. Sometimes keywords can be used to identify specific thing, but unfortunately some keywords may be used to identify multiple things. Here these days what you have typed are not falling into that category, right? Good, satisfied, awesome probably will be to identify the positive sentiments, whereas disappointed, sad, unhappy, awful, right, are to identify the negative sentiments. So we can have the clear distinguish. Yeah, cry, tears, words are coming in, right? So basically, you all agree with me. So next task is we need to break this data. We need to break this data into keywords. In NLP, we call it tokenization. We tokenize this data, this text into this. We tokenize this data, right? I'll go back to the slides again. What are the techniques of tokenization? Right. So these are from the corpus sample data, right? Not the actual data. I have taken this from the lecture slides of Andrew Nug, who is the pioneer. He's pioneering the NLP stuff from Stanford University. Now, if you look at this data set, so these are documents or uh, writings. Anthony and Cleopatra, Julius Caesar, Hamlet, Othello, and Macbeth. So Anthony keyword is available on these documents and this document. Now this one means available. Exist or not, that's it. Nothing else. Exist or not. If you look at Calpurnia not available in Anthony and Cleopatra. Julius Caesar's it available. So likewise. So we need to build this sort of a matrix. Term frequency matrix. Right? Now, again, there are many techniques to build this. Right? I'll showcase you the simple way. Right? So you can there are advanced techniques. I'm not going into those details because we are looking at the concepts of this. right? So then, right, so we have the data. We have the data, right? So we have 1,000 negative sentiments documents and 1,000 positive sentiment documents. So now we want to create a matrix out of it. So let's do that. So here you have a sorry, uh, technique called string to word vector. String to word vector. You identify the term. You have a string. You are converting that string into a word vector, right? I'm not going to use any other options. Let's discuss that little later, right? So we have this string to word vector. I will simply apply this, right? Now you can see your document now is a matrix. For example, if you look at this particular document, document number 3, uh, which is a negative sentiment, and if you go by this, you will see cross is word exist, acting word exist. What else? Right? So you can see if you go down the line, right? So for all of your 2,000 documents, it has generated this particular matrix. Now, you will have how many? Right. Now here, you will have 1,166 terms, keywords, right? So it has identified this many keywords. Now, if you are coming at this point, it is same as before. I mean, the diabetic data set. In diabetic data set, you had 8 columns and the classification column. Here, you have 1,166 columns and classification column. Only difference is the quality, the quantity, number of columns. So you have essentially converted your text into a structured data, right? So then, so after this point, let me generate a, let me do this. Now you can see earlier this was built in less than 1.1 second. But now the building takes more than 14 seconds, not yet completed. Right. So here you can see that now after this point onwards, things are same. Things are same, right? So you have the accuracy of 66 point and 33 data points were not correctly classified. This is your confusion matrix. This is your precision or the recall. We did not discuss precision, we have the recall as. But what are the enhancements or the issues that you see with this data set? Right? What are the enhancements or the issues that you see with this data set? Yes. Any issues you see with this data set? You are welcome to discuss workshop. This is not a lecture. This is a workshop. So you are welcome to discuss, or if you can't discuss, or you are not willing to speak, you can type. Anything you can type. That's fine. No issues. Articles could have been avoided. Good. Why? If I ask why, sorry. So articles are and the, right, and the. Why? Obviously, it doesn't add any context, right? It doesn't add any context. Okay, so let's do that. I'm going by you, right? I'm going by what you are saying. So I can do that. So here, those are called, right? Those are called stop words, right? Stop words. So let me select a stop word. I'm not sure. Select. Let me select distance here. Is still there. Right now you can see missing. Is gone. So I did whatever that was told to me, right? So that was gone now. And gone. Right there, I don't know why to this there. Right. So one is accepted. What else we can do? Think normally. Okay, I want to predict now. I have got this data, right? What else I want to? How can I improve this? How can I improve this? And after doing this, shall we do the another run and see whether we have improved our accuracy? Earlier it was 66, but now what? Meanwhile, it has improved a bit, I guess. Yes, 2% improvement. Not bad, but it has improved. Right? What else? What else you can think of? Yes, what else we can think of? How we can improve this? What about these numbers? Doesn't make any sense, right? These numbers. Okay, periodic symbols. Okay, let me do that as well. So there, what we can do is I can do a choose a tokenizer with alphabetic tokenizer. Right. So I'm choosing only the alphabetic words only. Right. So then, okay, others were gone now. So with that, I have how many data? Right, 1240. You can see, right, the words are the number is there is a reason for that. Let's not go into details of that. Right. So let's do a classification. Okay. Further improvement, very little, but improve. Going in the right direction. You can't say it can go down as well, but let's not. Right. What else? What are other improvements? So I'm going by your comments. What else we can do? Right. If you go back to the data set, this is my data set now. What else we can do? We can do a lot of things. What else? Any suggestions? Any? So we have accepted two things. Articles were removed and the symbols were removed. What else? Right. Now, if you look at this matrix, it says available, yes or no. It says whether these are available or not, yes or no. Now, what about the number of occurrences? For example, actor is available multiple times. For example, awesome is available 10 times. Right? So rather than going by the if exists method, we can go for the count as well. Right? So here the count is, again, as I said, right, not very good tool for in the industry purpose. So the option here is output word count true. Right? Output word count true. Then again, I have to open the file. So now if I go to this one, now you will see the numbers 2, 3, right? The 3 means in the document number 16, this acting keyword is available 3 times. Now we have another issue. Look at these two words, actor and actors. Actor, actors. Acting, action. Right? If you look at some words, they are contextually same. Yes, they may have a grammar differences. Run, ran, runs. Right? Actor, actors, acting. So to avoid those, we can use a stemming technique. Right? Stemming, again, all the details are available in the slides. I'll just go through with this one, loving stemmer. So I use the loving stemmer. Now, you can see actor and actors both are gone. Both are putting into one keyword. Right? There are stemming and lemmatization techniques, right? Which I'm not going into the details theory of stuff, but basically it brings into one form. Right? Right. Now, another thing is document length. Now, when you are looking at this document, this is where that variety factor coming in. Sometimes you may have comments in 2 lines. Sometimes you may have that comment in 1 page. Right? 1 page. Do you want that also to be taken into account? Sometimes yes. right? These are right. These are depends on your data set, right? Now, for example, if you are looking at Twitter data set, let's say, or now you call it X, probably you will see similar number of length is more somewhat similar. But if you look at newspaper articles, if you are looking at FB articles, length can be different. So here we want to normalize the data depending on the length. So if the length is very high, so for example, what we want to do is if we have this keyword in a shorter length, we will give uh, more weightage for that particular text, right? So we can normalize the data, right? Then what else? Then IDF, inverse document frequency. Now, when it comes to inverse document frequency, why it is important? Now, sometimes you might have the same text in all the same keyword, I should say, same keyword in all the documents. For example, these are movie reviews. So you will see the movie text, movie keywords, or the movie film keyword in most of the documents, right? So if you have the same keyword in many documents, you want to reduce the weightage of that, right? You want to reduce the weightage of that because it's no point that the same word is being used everywhere, right? So now, if you look at the stop words, which we used just before, are also some sort of a thing, and the will be available in most of the documents. But without doing any analysis, we can identify that those are languages. But inverse document frequencies, we use it for the terms that are mostly for the domain specific words which are used in most of the document. So we want to reduce the weightage of them, right? So we can do that. And let me open the file and apply it. So now you will have all these numerical values by you have applied some normalization, the normalization calculation, so log calculation. So with that, right? So you have some weird numbers, right? So then we can go for the classification and see. Right. So you can see the values, right? Uh, Probably the accuracies are a little less. That because that means some normalization techniques may not be applicable for this particular data set. Right? That is the meaning of that. Right? That is the meaning of that. Any questions? Anything you want to clarify? Before going into the right. So we have few other tokenization techniques discussed. Right. Now, normalization reduces the rare words, not the reduce, it increases the rare words weightage. It reduces the common, sorry, you are referring to the document normalization, right? Whatever. Uh, so there are two normalizations we did. Not sure you are referring to which normalization. We did the inverse document frequency normalization and the document length normalization. So in the document length normalization, what we do is, if the document is large in size, we reduces that weightage, that particular document. Inverse document frequency, the one which you are talking about, it reduces the weightage of the common terms. It increases the uh, weightage of the rare terms, right? Okay, if you ask the question, I will explain this from mathematics as well. Some reason I think I can't use that's fine. I'll use this, right? So this is your terms, right? Number of terms you have, term frequency, two terms, two occurrences, 5 terms. You multiply this by, I think I have this in slides. We want to high weight for rare terms, right? Those are there, right? So what we do here is, so capital N is the sorry, total documents. This is the term frequency, term frequency into, right? This is the total documents. This is number of documents that this particular term exists, right? Now let's say we have totally 1,000 documents, and we have a term called, let's say, movie, which is available in 950 documents. So your term frequency for that particular document will be multiplied by 1,000 into 950. Right? Now let's say your film term is existing all the documents. Right? So then log 1,000 divided by 1,000. That is log 1. What is the value of the log 1? Can someone tell me what is the value of the log 1? 0. Yes, 0. Right? 0 means, so if one term exists in all the documents, is that what do you call that all the terms will become 0. No point if that term is available in all the documents. How can we differentiate whether it's a positive or negative? You can't. Right? Now, for example, if there's a term, let's say awesome. Awesome is available on, let's say, only 100 documents. So then you have multiplied this by 1,000 into 10 log 10. Likewise. Right? Likewise. So you can see as soon as it goes down, right, this multiplication will become, this normalization will become increased weightage. Right. Any other questions? Any other questions? Okay. Now, now, now you said, right? Let me go back to your keywords that you said. Good, satisfied, awesome. Right? You are saying those will be used for positive terms. What if I use I am not satisfied? This film is not good. Right? Again, if I relate that to the song example that we were talking a little earlier. Now we think if there is a keyword called Hamtan that is related to University of Peradeniya. Right? That's a normal Hamtan is for Peradeniya. There is song by Kasun Kanghara saying its words goes like this: Hantana Natimut Japure. So if you look at that particular song, it's not talking about Peradeniya, talking about Jayavardhana Japura. There is a negative terms, right? Now, how we can account for that? So now, do you understand the difficulties and challenges that you see? Right? Again, the techniques that I discuss, you can't say you can achieve 100% accuracy. No, you can't. You can't. Right? You need to understand the difficulties here, challenges here. Right? These are the basics for these Gen AI tools. Basic, right? They are right. We can talk about the. We don't have time, but so these were used in terms of, and then this what do you call transformers are used for to identify the context, right? Attention is the right, so identify those things, right? Okay, let's not go into details of them, but these are the basics, right? Now, uh, right, so that is called let me quickly go back to that is called engram techniques. Even though I did not specify that, up to now we were using unigrams, one keyword, one keyword. But we can go for bigrams and we can go for trigrams. So let me explain what the bigrams are. Now let's take this word. I am running. Okay, I have another example. I am running, not walking. I can say I am walking. I am walking, not running. If you look at these two statements, two different contexts. Two different contexts. But if I go for metrics, right? Let's say this is the document 1, this is document 2. Now I will, without doing any stop keywords, right? Stop words, ignoring, I will draw the document term metrics for these two documents, right? So I am running, not walking. Document 1, I word is there, am. am is there, running is there, not is there, walking is there. Second one, I is there, am is there, walking is there, running is there, not is there. Now what? Even though these two are two different, these two have two different contextual meaning, because of our term metrics, there is no difference. There is no difference. Both are all are ones. Right? All are ones. So how can we improve this? Technique. Technique that we use is bigram or trigram technique. Now these are, so there is a suggestion that can we combine the not with the running keyword. That's what we are going to do. Thanks. Right? So in bigram, rather than using one word, we use two words. For example, then our matrix will become this one plus I am running not walking. Right? So I am exist, I am running exist, running not exist, not working exist. Let's go for the second document. I'll come to that. Walking not is also needed. Right? I am is there. Am walking is not there. So I need to have another term. Am walking. Walking not there. Walking not should be there. Walking not running. Am I made a mistake? Yeah, not running. Not running. So you can see not running. Now you can see because of this, these two documents have a different now. They are different now. Right? They are different now. I was told some generative AI tool using 10 grams as well. Right? Right? So you can see the difference. Right? So if you think this is also not enough, you can go for trigrams. But remember, as and when you increase the number of grams, it will increase your computational the processing as well, right? So it's something you need to understand. As always, nothing is free, right? Whenever you can have a best model, but that will run forever, right? That will run forever. So you need to strike a balance between those, right? So let's do that. So here you will see under tokenization, right? Under tokenization, you have, this is the problem with this particular tool. Okay, let me give me a minute. I'll need. Once again, I have to quickly disable the taskbar. Right, so you have the n-gram tokenizer. There you can define. So here minimum is 2 to 3, right? So tokenizers are defined, and then you can open the file again and apply this. So now it's taking little time. You can see the differences. It takes time now. Let me edit this now. Now, when you are doing n-gram technique, these will not be the removed, but you can manually remove them. If you think you don't need them, you can click them and manually remove them, because now I'm using a different technique. Right, so let me do a, okay, let me, sorry. If I show you now, you can see those are good, great, all will be included, right? So likewise, all terms are included, and then you can run the this might take some time. So it has gone to this level now, right? Right. So, but now something important. Let me show you the tree diagram. So you remember the tree diagram for this. Very simple. Let's look at the tree diagram. I hope okay. Right. So this would be my tree diagram. You can see how complex it is. It's not very to screen, right? Okay. Right. So you can see the tree diagram, how complex it is. Right. Not the very easiest diagrams. Right. Not the very easiest diagrams. Obviously, it's complex. Right. That's what I said at the start. They are complex in when it comes to natural language processing. They are very complex. Right. Any questions? Okay. Any questions? Anything? So similarly, you can use this for clustering, document the natural grouping, as well as for any other techniques as well. I use only Veka. There are many tools available, right? So you can use Orange data mining tool, which is little handy, right? And if I if you have no questions, I can showcase you the Orange data mining tool as well, right? So again, um, so these again tools are there, but you need to understand the concepts behind these tools, right? Then there is a Azure mining tool, Azure data mining tool as well, where you can it has many other advantages such as what do you call you can, I mean, if you look at the Veka, you would see you are running now. When I want to run it again, I have to start from the very beginning, right? No configurations, nothing at all. And also when it comes to text data, you have a large volume of data, right? So I was showcasing 2000 records, nearly 2000 records, which may not be really enough to showcase the showcase large work. So when it comes to text data, you have to store this in somewhere. So if you are using Azure machine learning, you can store your data in a data lake, right, which is the typical platform. And then from that data lake, you can retrieve this data. So when in the industry perspective, when you're looking at the industry perspective, people now, if you look at the industry perspective, let's say these will not be done by one team, right? Data extraction part will be done by another one team. This modeling part will be done by another team. Consumption part will be done by another team. So here you need multiple people here, right? We call it ML of machine learning operation. Like you may have learned DevOps. Like DevOps, you may see people are the machine learning operations as well, where multiple people get together to get results. So in that particular case, these tools may not be very helpful. As I said, these tools are very good at showcasing some work, right? To be very honest with you, I haven't seen a tool like Veka where you have all the options, right? If you go for what do you call Azure machine learning, you have to write your own scripts to do the document normalization. They have TF, IDF is there, but the document normalization is not there, right? Same with the Orange data mining tool as well. But Veka, the challenge in the Veka is incorporating the industry need, right? So when it comes to Azure machine learning, the people who are extracting data can extract this data and store this data in a Azure data lake. So then Azure machine learning can access this data and generate the learnings, knowledge. And from that, uh, the it can be used by the consumers by using a web service, right? So they have that particular web service option as well, where you don't have to build uh, another application for it. For example, you can generate the web service, and web service can be connected to the Excel sheet. For the example, the previous example that I was telling you, an organization working on the employee sentiment, HR team, they were not using any other tool. They were simply using the Excel sheet, right? Where from the what do you call the uh, right? What do you call the are they freely available? I'm not Dinusha, not what you are referring to. Veka is freely available. Uh, Orange data mining is freely available. Azure is Azure machine learning was there was two services. One was discarded this year, so that is no more there. And if you want Azure Machine Learning, you can get 100 credits, free $100 credit, free credits to uh, to use these features, right? So I'm not sure which tool you are referring to. If you are referring to Veka, it's freely available, right? It's freely available, and if you are talking about data Orange, it is freely available as well, right? Uh, right. Azure Machine Learning, it's not, like, how can I say, not totally free, right? Not totally free. It's 100 credits are free, but I'm not sure if you are attached to a university, you can get the free license up to some extent for 4 years or whatever. You can get to some free credits, right? For the university student license. Underneath that, you have free services as well, right? Right. Any other questions? I'm done with my presentation. Any other questions? Right. If right, there is a question from Harendra. What would you recommend? Orange data mining or Veka? Sorry, uh, Veka Explore easy to use. Easy to use. Harendra, I guess, right? So Orange, both tools are not okay. Both tools are not recommended for industry usage, right? If you are looking at learning perspective, I would recommend for the text analytics, I would recommend uh, Veka, than Orange, because I haven't seen all the features that can be used for text analytics in Orange. There are some features, like there are some good features. Now, for example, uh, now one okay, since you asked this, now when we build the what do you call term metrics, right? That term metrics we go by the keywords, but in Orange you can identify the terms or the keywords with respect to the whether they are a verb or a noun, right? That is, now for example, the what I said before, uh, chairperson, chairing the session, right? So that for the so that first chair would be the adjective noun, and the other one is the verb. So in your term frequency matrix, it says first identify the verbs and the noun separately, which is available in the Orange. But since it doesn't have all the other features like what we did, right? I would recommend for you to use Veka Explorer for purpose of learning. Remember the keyword, right? Purpose of learning, not for the industrial use. Industrial use, I would say you can't use Veka because it is one thing is single thread, right? I was using 2,000 records. If you are using, let's say, 100,000 records, 100,000 records, this will crash, and it is single thread application, right? It's single thread application. Orange is also same. So, right, if you are doing a large processing, it might not help. And also how you keep this model. There is no way to store this model, right? You have to redo the models again and again. So which you can't use. So these tools are very good for modeling perspective, not for the industry or the real world usage perspective. Hope I did answer your question, Harendra, I don't know. Any other questions? Okay.
All right, I think we can wind up the session. Very good afternoon to all of you, President of SLI, Conference Chair, SLI members, and Mr. Dinesh Asankar, our esteemed resource person, and dear participants. I am here with heartfelt gratitude as Vice President of SLI, having had the privilege to listen to your very fruitful session. And I hope all the participants gain a lot of information and lot of insight into uh, practically working in this area. A big thank you, Mr. Dinesh Asankar, who you are sharing with us all the experience and knowledge in this area, in your expertise. And we appreciate the time and effort you dedicated to making this event a valuable learning experience. Dear participants, your active engagement and eagerness for learning is also an encouragement for us and the organizing committee. And thank you very much for being with us. With that note, I would like to uh, end the session today. So thank you again, Mr. Dinesh Asanka and all the participants on behalf of SLI.
Thanks, Professor.